Hello learner, welcome to Manifested Online Classes. My name is James Kenyani. We are going to continue with our topic longitude and latitude. Today in this lesson we are going to look at distances between two places on a circle of latitude. Distances between two places or distance between two places on a circle of latitude. So distances between two places on a circle of latitude. The objective of this lesson is to enable the learner to calculate distances on circles of latitude. So learner, the objective is to enable the learner to calculate distances on circles of latitude. So before I continue, one would like to wonder, what are these circles of latitude? At the center here, learner, that is the equator. At the center, we have the equator. It even cuts through Kenya. So this is the equator. So the circles of latitude are those circles parallel to the equator. As you go north, like this one, that one towards the north, and those ones below the equator towards the south. So we are going to calculate those distances like I've shown on that. This is the equator, learner. The latitude of that small circle is theta. The latitude of that small circle is theta. The distance now we are getting to get concerned with is xy. It is appearing on a small circle. It is appearing on a small circle. So x gives the longitude difference. X gives the longitude difference. So that is figure K, learner, isn't it? That is figure K. In figure K, x is the longitude difference. X is the longitude difference. So in figure K, so we have to get those parameters correctly. X is the longitude difference. X is the longitude difference. R is the radius of the small circle. Of latitude, a small circle of latitude theta. So he said when he mentioned latitude, it is to the north or to the south of latitude theta. Of latitude theta. When we are calculating differences, calculating distances, we always assume that the Earth has a radius of, we always assume the Earth to have a radius of 6,370 kilometers. We always assume the Earth to have that radius. Now we are interested in distance x, y. So the distance we are concerned with is xy, and that is a small circle. That is a small circle. So the distance, arc distance, xy on the small circle will be given by, is equal to, you take the longitude difference, which is x, divide by 360 degrees times 2 pi times the radius of that small circle. But we realized that in the previous lesson, we got a relationship between r and r, the big R. So always R here is 6,370 kilometers. We already got the relationship of R and the big R, but R is equals to R cos theta. We proved in the previous lesson. So that distance xy will be equal to longitude difference x divided by 360 degrees. Divide by 360 degrees times 2 pi r cos theta, where theta is the latitude of the small circle. So learner, it's very easy now to get the distance on a small circle once you know the longitude difference. Once you know that longitude difference. So that is how you get that distance. And once you know the radius of the earth. Once you know the radius of the earth and you know the longitude difference, you can get that distance. But there is what they call the nautical mile. So that's why I come here and write relationship between the nautical mile, nautical mile, and the kilometer. So learner, sometimes they'll ask you to calculate this distance in nautical miles and sometimes in kilometers. So it's very good for you to know the relationship between the nautical mile and the kilometer. So it all starts here. 1 degree on a small circle, on a big circle, this is 1 degree. It is believed to subtend 60 nautical miles. 1 degree on a small circle, 1 degree on a big circle subtends 60 nautical miles. So there you check very careful. We can calculate this distance in kilometers because this is R. Because I'm talking of a big circle. This in kilometers is equal to 1 degree over 360 times 2 pi r. If I calculate that, I'll get kilometers. So I'll come here, because it is 1 degree, it is still the same distance, and the radius still remains the radius of the earth because it is a big circle. So this will come to 1 over 360. Take your pi to be 22 over 7 times 2 times 22 over 7 times 6,370 kilometers, which is the radius of the earth. Now, 7 goes there, 1, 7 goes there, 910. 910. So we have, this works to 44 times 910 over 360. 44 times 910 over 360. So we work out that with the calculators. 44 times 111.22. This comes to 111.222 kilometers. So it means, therefore, Lana, it means 60 nautical miles is equal to 111.222 kilometers. Therefore, 1 nautical mile will be equal to 111.222 divided by, say, 60. That will give you that relationship, because sometimes they'll ask you to work in nautical miles. So once you've got in nautical miles, it is easy to convert to kilometers. So working out that, we get 1.853. So 1 nautical mile is equal to 1.853 kilometers. That's very important, Lana, because I would have still asked you to calculate that distance in nautical miles, having given you the longitude difference. So Lana, note that all these lines above the north will be small circles. The only great circle in that direction is the equator. So having done that, we can look at a small example. So Lana, that is the example. It related to what we've been doing. So it goes, the distance between two places, P, 30 degrees north, it is on latitude 30 degrees north and 60 degrees east, and Q, x degrees north, 60 degrees east is 2,460 nautical miles. What is the possible latitude of Q? What is the possible latitude of Q? So it's good to have a small sketch, a quick sketch. So that's the equator. So we have, this is 30 degrees north, 60 degrees east. So you can just have your Greenwich Prime Meridian. Is prime meridian. So 30 degrees north will be somewhere here. Then 60 degrees east. So you draw that. Have your good sketch, given that is the center. This will be the 30 degrees north. This is point P. Point P. So if we have a center of the earth, this will be given by 60 degrees. It is 60 degrees east of the, not here, so P somewhere here. So P will be here, east of the Greenwich Prime Meridian. So this will be 60 degrees. That is P. That is point P. There is still another point. It is still on the same longitude. There is a place still on the same longitude, but it is still east. We don't know that distance. We don't know what is the possible latitude of Q. So it can either be to the west or the east. So here the longitude difference is not known. And since it is a small circle, distance on small circles is given by theta over 360 times 2 pi r cos theta. Or if we are using nautical miles, it will be given by 60 nautical miles. So you check here, this could be the longitude difference. This is the latitude of that circle. That is the latitude of that circle. In this case, it is 30. In this case, it is 30. So it's good to denote these with a different letter so that you know that this is the latitude difference and this is the longitude difference. Or if we are using nautical miles, it will be x times 60, x degrees times 60 cos theta. So you be very careful, where x is the longitude difference, and theta is the latitude of the small circle. So you watch that learner. Since in our question they are dealing with the nautical miles, we shall not use these. We shall use the second one. In fact, x is the one they are looking for. X, the longitude difference. X, so what is the possible latitude of Q? So we be careful. Possible latitude of Q. So having been given that, if this can only happen if x, this x, or latitude difference. It can also be a latitude difference. So this can be a latitude difference depending on where you are calculating. So the value of Q is not known. It is either west or it is either north of P or south of P. So we know x degrees, therefore x degrees times 60 times 60 times 60 times the cosine of that latitude times cos so 1 x times 60, because it's a big circle, that latitude difference is equal to 2,460. So when we get x, because here it can either be a latitude or a longitude difference depending on whether we are talking of a small circle or a big circle. So x degrees will be equal to 2,460 divided by 60. So on working out, you'll get 41 degrees. That is the latitude difference. Latitude difference will give you 41 degrees. So it comes to a place where you have to reason. If I have 30 degrees, because that was the latitude of that, I have 30 degrees. I have 30 degrees. There are two possible values of P, two possible values of X. So the two possible values of X are, the two possible values of X are 30 degrees plus 41 degrees. So that will give you 71 degrees north. You can either go north or you go south. Or you can have 30 minus 41. Working out that, it will give you 11 degrees south. So you can have two values. So you'll ignore the negative value. You'll ignore the negative value. So the two possible values of X are that. So those are the two possible values of that. So let's have a quick assignment. So Lana, before I read through that assignment, note that if you find the longitude is fixed, that distance will be on a great circle. That distance will be on a great circle. But if the latitude is fixed, that distance will be on a small circle. That's why you'll come in and have that. You'll come and have the difference in longitude times 60 times the cosine of that latitude. Like here, the latitude is 30. The latitude is 30. So we go through the assignment. Calculate the distances in nautical miles and kilometers along the circle of latitude. A, 30 degrees north, 20 degrees east, and B, 30 degrees north, 80 degrees east. B, 1, 10 degrees south, 60 degrees west, and 10 degrees south, 20 degrees. So these are questions where you are calculating on a small circle. You are calculating on a small circle. So you are actually going to get the latitude difference and you use that. You'll use this one for that assignment. So thank you for the audience, and let's meet again once you've done the assignment. So bye-bye and have a nice time.